say a man's home is his castle. And at the nucleus of that castle is a tile and porcelain sanctuary. We go there when nature calls, when we need to clean up, and when we need to escape. The central component of most bathrooms is the tub. And for more than 100 years, they've pretty much been made the same way. At the Kohler factory in Kohler, Wisconsin, every day thousands of tubs are created. Their basic ingredients, steel and enamel. The bathtub begins in a vat of molten metal. The liquid steel is then poured into earthen frames and allowed to cool. Once the frame is removed, the steel is buffed out by hand and then heated to 1700 degrees. When it's literally red hot, layers of enamel powder, essentially ground glass, are sprinkled over all of the tub's visible parts. The heat melts the glass and causes it to adhere to the metal. A gleaming fixture results. Just add water and you're ready to enjoy. But before there were tubs, and even plumbing, things were a bit different. Primitive humans doubtlessly sought out streams and ponds in which to clean themselves. But once these hunter-gatherers began to settle down into cities, they had to develop ways to bring the bath water to them. It began in the Indus Valley, in modern-day Pakistan. In 2500 BC, India's ancient ancestors, the Harappans, created the forerunner of the modern bathroom.
The Harappans were famous for their organization of their houses. They were the first really to lay out cities, and in those cities to take into account waste management.
Virtually every Harappan home had a primitive shower stall with drains where they could douse themselves with buckets of water. They did, however, lack an efficient water delivery system. The water had to be drawn from nearby wells and carried into the home.
That water was used for their baths and for flushing their toilets, and it would all drain into a central sewer system, and that sewer system would in turn take the water and dump it into the nearby river.
But running water as we know it was conceived by the Greeks. Buried beneath their cities was a system of terracotta pipes linked to local rivers and springs.
The Greeks developed the building of aqueducts to bring fresh water into their cities, both to fountain houses where people could go and get drinking water, and especially to the gymnasium, so that you'd have running water for the bathing after exercise.
A Greek bath lacked two things we take for granted: hot water and soap.
What they would do is they would take a hooked metal implement called a strigil and scrape either themselves or a friend, or more likely a slave, scrape all the caked dirt off, and then wash.
The Romans took up where the Greeks left off, installing an aqueduct system beneath the ground that stretched almost 200 miles. Water flowed from distant mountain streams all the way to Rome. Today, all that remains of the system are ruins of the bridges that supported the above-ground stretches of pipe.
As the Romans became more familiar with Greek culture in the late 3rd and 2nd centuries BC, they picked up from the Greeks the idea of public baths.
The abundance of water flowing through the aqueducts enabled Roman engineers to construct the greatest public bathhouses the world had ever known.
The baths were so large, it's hard for us to conceive of them. They could handle 2,500 men or women in the women's bath in a single day, and you would go for the entire day.
The water in the bathing pools was hot. Directly below were massive furnace rooms burning wood and coal. The flames scorching the stone floors of bathhouses were powerful enough to fill the rooms with sauna-like heat.
Bathing did become an almost universal phenomenon throughout the empire, thanks to the building of bathing facilities in virtually every Roman town.
But when the Roman Empire finally fell, bathroom technology went with it. Without the Roman aqueducts, fresh water would once again have to be lugged from wells. It's no wonder that bathing fell out of favor for more than 10 centuries.
What people don't appreciate today is during long periods, during the Middle Ages, even into the Renaissance, people would bathe maybe once a year, and that was considered all that was necessary.
In the 18th century, bathing began a long overdue comeback in Europe. Fancy new copper tubs became all the rage, some shaped like giant boots. Benjamin Franklin raised America's awareness when he brought one back with him after visiting France. Early versions of the bathtub's cousin, the shower, began to appear in the 1800s. Water flowed down from an elevated tank through the shower head, as long as the limited supply of water lasted. Bathroom tech could go only so far until engineers could construct water delivery systems able to service entire cities. In 1842, New York City paved the way. The system's designers harnessed a fundamental law of nature, that water flows downhill. Your city's system follows the same principle. Water is pumped to the top of giant towers that are linked to pipes beneath the streets. Since the tower is higher than the water's final destination, gravity maintains pressure and forces the water through pipes to your tap. After water is used, gravity once again carries it away through sewer pipes angled downhill. During the 19th century, more and more cities followed New York's example. One turn of a handle brought water into bathrooms. The only problem is that it was all cold. Some bathtub makers trying to solve the problem created models that endangered their customers.
They were heated in a terrifying way. Particularly the General Gordon gas bath, which was a flame, a naked flame beneath the tin bath that scorched the bottom off your behind.
In 1889, Pittsburgh entrepreneur Edwin Rood invented a more practical alternative, the home hot water heater. It used coils of copper pipe stacked atop a small gas furnace. Water passing through the copper pipes was quickly heated. Once it left the heater, the hot water could then be piped directly to sinks, tubs, and showers.
It made it very convenient, certainly, to have warm bath, which was obviously more pleasant than a cold or tepid bath, and the ability to drain the water away without the use of servants also made it more accessible to everybody.
During the 20th century, engineers developed the modern design, in which water is heated inside a steel drum. The newer models were outfitted with critical safety devices, such as metal plugs designed to melt and release the water if the temperature rose dangerously high. Sometimes they didn't. The superheated water inside the tank would explode, sometimes injuring or killing unsuspecting homeowners. The Watts Regulator Company solved the problem in the 1930s. Its engineers developed an automatic temperature and pressure safety release valve, which allowed pent-up heat to vent before reaching critical mass. Throughout the 20th century, the American bathroom continued to evolve. At first, they were almost impractically small. By the 1950s, architects were designing larger, more comfortable spaces, but they often forced families to share just one bathroom. The bathroom would evolve still further with the arrival of the master bath in the 1970s.
Bathrooms began to be bigger and walls came down. It was very typical to see a big whirlpool tub right in the middle of a master bedroom. It was an experience. It was the sort of the experience generation when more was more.
The size of the new whirlpool baths, and not to mention the weight of all that water, required new tub-making technologies. Traditional steel and enamel tubs were out, and heavy-duty plastics were in. To make a Kohler Vicryl tub, a bundle of plastic material called a load is placed inside a reverse mold of the finished tub. Once the mold closes, the tub is literally pressed into shape. After it's removed from the mold, the tub is cleaned and outfitted with water jets.
The daily cleanliness is no longer a question. It's something that has become accessible to everyone. But it's just how much pampering can you pack into that room is the true measure of luxury in today's bathrooms.
But relaxing isn't the only thing we do in the bathroom. Next, we'll crack the veneer on the porcelain god. This porcelain wonder is the nucleus of every bathroom. Every day in America, we flush down at our own waste and 7 billion gallons of water. Most of us don't give the toilet a second thought until something goes wrong with it. But the Japanese are transforming it into a high-tech art form.
Their #1 toilet manufacturer, Toto, has come out with several different designs, basically incorporating the bidet in with the toilet, so that as you're going to the bathroom, you can push one button and an arm swings out and shoots water up on your rump. You push another button and it'll shoot hot air to dry off your bottom. And they also have heat warming seats. It can be a problem, though, if you sit down and you push the wrong button at the wrong time.
For most Americans, the functional white commode is still the standard. And by any standard, the modern toilet is a spectacularly successful invention. It's durable, doesn't require a power supply, and it rarely, if ever, breaks down. Each and every toilet begins as a liquid clay mixture called slip. The slip is poured into molds and allowed to harden. Once it's removed from the mold, the toilet's clay surface must be smoothed out by hand. Any imperfection will be plainly visible in the finished product. Next, robotic arms spray the toilet body with glazed paint, and it's baked for 36 hours inside a huge industrial kiln. After the toilet is removed from the kiln, it exhibits the familiar porcelain veneer. But before the toilet, bathroom sanitation was primitive, at best. While the Harappans and the Minoans used rudimentary forms of plumbing to flush away their waste, elsewhere in the ancient world, bathroom technology consisted of clay pots.
I don't know if the Greeks invented the chamber pot, but they certainly used it. There are numerous attestations to it. Wealthy men would even have a slave who was called the lasonophoros, the chamber pot carrier, whose job it was to come in and remove the chamber pot and clean it out.
The Romans put the chamber pot carrier out of business with the development of public latrines, which were essentially seat holes carved into stone benches.
You sit down over one of the holes, and under the hole is a trench with water running through it. And so whatever you deposit into the hole falls into the running water and gets swept away immediately.
The Romans also innovated the precursor of another bathroom technology, the pay toilet.
The latrines were initially provided free of charge, but the Emperor Vespasian began to raise funds from the use of latrines. And his son is said to have protested and said, "Surely, Father, that's not proper to get money from such a dingy business." And Vespasian held out a coin to him and said, "Money doesn't stink."
But taxing the toilets couldn't save the Roman Empire. And with its fall, toilet technology would be set back for centuries.
The only thing that you had indoors for the next, really, 1,000 years was the chamber pot, which was really something of a horror story. It was a convenience in one way when you needed to go in the middle of the night, but then who emptied it in the morning?
Some people didn't even wait for morning.
At nighttime was the time when people would dump the contents of this chamber pot outside their windows into the streets below. And the idea that a man walks on the left side of the female dates back to this time. It was polite for him to get hit by the contents of the chamber pot and to spare the woman.
People often took their chamber pots with them when they traveled. Pots could also be rented for parties or even pit stops.
Another rather intriguing figure of medieval sanitary history is the human lavatory, who was a man who'd go along with a great black cloak down the streets, holding a stool and a chamber pot in each hand. And when you paid him a penny, he'd put the stool down with the chamber pot on it. You would sit on it, and whilst you're relieving yourself of your troubles, he would surround you with his black cloak. And then you'd get up and go on your way.
In the 16th century, flush toilet technology made its debut in England.
The first nearly modern toilet was made for Queen Elizabeth I in 1596. It was made by her godson, Sir John Harrington. He made it to get back in her good graces because she had banished him from court for using foul language. He came up with a really clever device. It had a tank at the top, it had a valve you opened to let water down, and there was a trap door that you could close after you used the toilet.
Harrington's primitive toilet had a critical design flaw. The pipe beneath the bowl was vertical. Waste went straight down, and sewer smells came straight up.
The Queen complained that fumes came up from the cesspool, but it was a problem that her godson was never able to solve. What he did foolishly is he wrote a book on what he called her privy imperfection, her toilet, revealing not only how the toilet worked, but some personal secrets about the Queen, which incurred her ire, and she banished him from court again.
After Harrington's toilet got the royal flush, toilet technology continued to remain low-tech, and even no-tech.
You realize how bad the situation was if you look at the Palace of Versailles. A fortune was spent in constructing it. It had these wonderful hall of mirrors, elaborate chandeliers, and you might have 1,000 people being entertained, eating and drinking copiously, but where did they go to the bathroom? There was not a single bathroom in the entire elaborate palace. And the answer is they went in the stairwells. And one of the reasons the French applied so much perfume during that period was to overcome all of the indoor odors from people relieving themselves.
Outside Versailles, people were relieving themselves in indoor cesspits. They were simply benches or seats perched over holes lined with wood, stone, or brick. Their main drawback, aside from the smell, was that you had to pay night soilmen or rakers to clean them out. In the 18th century, American colonists modified the cesspit by taking it outside and constructing a small wooden shack over it. The outhouse was born.
They would place the outhouses far enough from the house where there would not be problems with smell or with seeping into the water supply of the house.
In 1775, while America was embroiled in the Revolutionary War, back in the mother country, another revolution was taking place, this time in toilet technology. British watchmaker Alexander Cummings invented a toilet with a twist. Literally, the pipe beneath Cummings' toilet bowl curved backward in a distinctive U-shaped bend. This allowed water to pool in the pipe, cutting off smells from below.
It actually is the modern toilet because we still have that water separating us from the cesspool today.
Over the next 100 years, several inventors improved on Cummings' design. The key innovation was a water siphoning system to force waste through the base of the bowl with unparalleled efficiency. What worked then still works now. Once the toilet's flush handle is pulled, a valve inside the holding tank, called the flapper, opens up. The water drains quickly into the bowl through a series of angled holes under the rim. The swirling water exits down the waste pipe past the U-shaped bend, creating a siphoning effect that pulls the water from the bowl. The man who's often credited with inventing this flushing wonder probably had little to do with it. Thomas Crapper. Yes, he really existed. However, the Victorian-era plumbing magnate nevertheless earned his place in toilet history, if only by selling lots of them.
During World War I, when American soldiers were stationed over in Britain, they would come across a lot of these toilets, and they started the euphemism of, I'm going to the crapper, and they based it on what they saw on the toilets, which said Thomas Crapper and Company.
While Crapper was making a name for himself, two enterprising brothers were busy inventing the toilet's most essential accessory. Next, everything you always wanted to know about toilet paper, but were afraid to ask. With every year, bathroom technology is more and more about satisfying our needs for comfort and convenience. But beginning in the 1990s, toilet manufacturers adopted a new priority: the environment. Engineers had to respond to strict new water conservation laws. Up until that time, the average toilet used 3.5 gallons per flush. they had to invent more efficient models that used only 1.6. They eventually developed improved water channels to help increase the velocity of the water. One American Standard low-flush toilet is so powerful that it's been demonstrated to clear 11 golf balls in a single flush. As this test video demonstrates, not all manufacturers' low-flush toilets are up to the challenge. But American Standard, at least, has set a new standard in water efficiency. Of course, the item most commonly flushed isn't golf balls. It's toilet paper, which, as you might expect, had a long and winding history. Although the Chinese invented paper in the 2nd century, it took them more than 1,200 years to get around to using it in the bathroom. They finally did so in 1391 AD, but it was strictly for the use of emperors. And what did that leave commoners?
People generally used their hands, and currently in many countries around the world where paper is a premium, people continue to use their left hand. That is why when you travel to parts of the Middle East, Southeast Asia, and Asia, you won't find any left-handed people. Everyone there is right-handed because the left hand is considered unclean.
In medieval Europe, commoners used hay, grass, and plant leaves to clean themselves. In early America, millions used corn cobs. The cobs were softened first by prolonged soaking in water.
The corn cobs were generally given to the pigs to eat, and then when the pigs were finished with them and there was just the cob left, they would take those and use them to wipe themselves. So there was very little waste.
When mass-published newspapers and catalogs became commonplace in the 19th century, Americans finally said goodbye to the corn cobs and hello to Sears and Roebuck.
People would take the catalog, hang it in their outhouses, and they would read from it while they were doing their business. And at the finish of the business, they would tear off a piece and use it to wipe themselves.
But things changed in the 1920s.
Unfortunately, Sears started using glossy print paper. The absorbing benefits of the catalog kind of lost it. So you didn't see so many people using the Sears catalog as toilet paper from then on.
By that time, however, consumers had another option: real toilet paper. The idea of selling paper for that purpose had been around since before the Civil War.
There was a man named Joseph Gayetti. He was a New Yorker and he had a paper business in New Jersey. He was the first person who actually took paper, cut it into sheets, into small sheets, and sold it through drugstores as therapeutic paper.
But the product flopped.
The people who bought them thought the paper was too nice and ended up using it as stationery, writing on it, and still using their catalog.
In 1879, entrepreneurs Irvin and Clarence Scott began selling rolled toilet paper. It was made from tissue paper, bought from other manufacturers, which they cut up, rolled, and repackaged. Although there have been some improvements over the years, today's toilet tissue is made basically the same way. Like all paper, toilet tissue begins life as a tree. Trees are logged and then processed at pulp mills, where the wood chips are ground up and mixed with chemicals and water. The concoction has the consistency of oatmeal. The wood pulp mixture is then fed into the 4-driner paper-making machine.
If you can take 5 trailer trucks and put them in a bundle, that's how big the machines are.
In the 4-driner, the pulp is laid onto large screens and air-dried with heaters. Once a section of paper is dry, it's rolled forward and more pulp is added to the screens. In this way, a continuous roll of paper is produced. These rolls of paper, called parent rolls, are massive. At the Angel Soft plant, a typical one is nearly 12 feet long, 6 feet high, and weighs close to 3 tons. Paper from the parent roll is fed into another machine, where it's wound onto individual 12-foot-long cardboard tubes. Along the way, the paper is stamped at regular intervals with a sawtooth knife blade, resulting in perforations. The long rolls of toilet paper, called logs, are removed and then cut to their familiar size with a precision saw.
It actually runs at such a high speed and is so sharp that it actually slices through the rolls without mashing or crushing the cores of the rolls.
Today's toilet paper is far softer than the Scots Victorian-era counterpart. Modern manufacturers use chemicals to completely dissolve wood fibers in the pulp mix. The process was pioneered in the 1940s by the Scots' competitor, Northern Tissue, now Quilted Northern. Their advertisements referred to their product as splinter-free. Today's factories can produce up to 5 million rolls of toilet paper every day. It's a good thing, because Americans use 26 billion rolls of toilet paper each year, and that number just keeps on growing. While rolled toilet paper took only a few years to become established, another novelty item, the toothbrush, took hundreds of years to catch on. Next, we brush up on oral hygiene. Aside from visiting the toilet, the second most common act performed in the American bathroom involves the daily care and maintenance of teeth. Today, there's a dazzling array of choices. Motorized and manual toothbrushes, assorted toothpastes and mouthwashes in a myriad of colors and flavors. But the first instrument to clean teeth wasn't a brush. It was a stick, used by ancient Egyptians in 3000 BC.
They actually had a special tree where they break off branches, and these branches frayed very easily. They were called chew sticks. You would fray the end, chew on it, and then you'd use the frayed end to clean your teeth.
The chew stick, along with its smaller cousin, the toothpick, were the principal tools of oral hygiene for more than 45 centuries. But in 1498, the world's first toothbrush appeared in China.
We don't know if they first used bone as a handle or a bamboo handle, but we do know that the bristles were boar hair inserted into a straight handle at 90 degrees and would have looked much like brushes do today.
The boar bristles came from the backs of Siberian hogs. The region's cold climate gave their hair its proper thickness.
Here you have your basic bone handled toothbrush. The boar's hair bristles have been inset, and they have also been cut on a curve to adapt them to the teeth. You can see there are a lot of bristles in this brush, much larger than a brush today.
And modern angled toothbrushes are nothing new. In the 19th century, toothbrush handles made from cow bone were carved into many different shapes and sizes.
This is a strip of bone that's been cut. This will serve as a toothbrush handle blank. The basic shape is carved from the bone to get your toothbrush shape. That basic shape is further refined, and this is polished. And at this point, the holes are drilled in the head of the brush, and then the boar's hair is inserted into the holes and secured with usually copper wire, and then the boar hair is trimmed to the desired length for the brush. And you have a completed boar hair bone handle toothbrush.
Given the painstaking work, it's not surprising that early toothbrushes were often very expensive. People generally shared them.
A family may have had one, if they had any at all.
Early in the 20th century, with the advent of plastics, bone handles were replaced by celluloid ones, but the boar hair remained.
Animal bristles remained the standard up until 1938, when the DuPont Chemical Company introduced the first nylon toothbrush, nylon bristles. And the benefit was it did not hold bacteria and it did not pull out of the brush.
The DuPont company actually invented nylon in 1938 for use in toothbrush bristles, but it didn't become widely accepted until you get into World War II, and the supply of boar hair is virtually cut off from the United States. So they had to have something to replace that, and this something was DuPont's nylon.
The first toothbrush made with synthetic DuPont bristles was called Dr. West's Miracle Tuft. Others followed. A typical ad from the early 1940s featured grateful boars. Today's nylon bristles are produced much the same way as they were in the 40s. First, high-speed machines insert the bristles into the plastic handles.
You heat the handle, create the hole, insert the tufts into the handle. That cools down, the head solidifies around the tufts. You trim them, and then they are polished so that the ends are not rough but are smooth, rounded edges.
Another revolution in toothbrush technology came in the 1960s with the arrival of the first electrics.
You brush your teeth with 3,600 up and down brush strokes a minute.
Since then, microtechnology has allowed for smaller, more powerful, and cheaper brushes.
That's where the industry's headed. The smaller, disposable, battery-powered electric toothbrushes. Although I don't think handheld manual toothbrushes will ever, at least in my lifetime, will ever disappear.
Of course, where oral hygiene is concerned, toothbrushes are only half the story. There's also toothpaste, which, like the chew stick, dates back to the Egyptians.
They made a toothpaste using a ground pumice stone, like volcanic ash, and they would mix it with a wine vinegar, something acidic, to actually clean the teeth, and it worked very, very well.
The first modern tooth cleaning products were tooth powders. Users had to create their own lather.
You pour it out in your hand, get your brush wet, dip your brush in your hand, and start brushing your teeth.
Toothpastes arrived during the Victorian era. They were easier to use because they were already mixed with water. Early toothpastes were upscale items, sold in fancy porcelain pots. In 1892, a Connecticut dentist named Washington Sheffield became the first to sell toothpaste in collapsible tubes. Sheffield's son got the $1 million idea after visiting an art store and seeing tubes of oil paint. Dad made it a business. Colgate followed suit in 1896.
And the Colgate way stops tooth decay best.
But Sheffield's innovation continued to squeeze out profits.
That company is still in existence today. They make toothpaste. They make any kind of tube you could possibly think of.
With the introduction of tubes, toothpaste manufacturers had to develop specialized machines to fill them. Then as now, paste is injected into the tube. The bottoms of the tubes are then folded over and heat sealed. Modern toothpastes come in pastes and gels, and in some cases both. But how do they get the toothpaste to come out in stripes? Well, they put it in that way, thanks to the multi-part injector nozzle, which allows them to fill the tube with 10 distinct streams of dental cream. Then you just squeeze the tube, and voila, you've got striped toothpaste. Today, the emphasis isn't just on cleaning teeth, but whitening them. Special toothpastes and plaque rinses have been formulated for that purpose. But the world's first tooth whitening mouthwash was reportedly developed back in Roman times. And you'll never guess what was in it.
Catullus, the Roman poet, makes fun of a Roman rival of his, and he alleged that this man's particular region of Spain, it was the practice to clean one's teeth by swishing one's mouth out with early morning urine. And he pokes fun at the man for this and says, "I'm surprised that you go around smiling, because don't you understand that everyone realizes the whiter your teeth are, the more urine you've been drinking."
But the Romans weren't alone. 16 centuries later, Pierre Fauchard, the father of modern dentistry, also advocated cleaning teeth with urine.
He, through experimentation, had realized that urine had something in it that was beneficial to the teeth and health of the gums.
The mysterious chemical was ammonia. Now, if you've ever not cleaned your cat litter box, you know how pungent the smell of ammonia can be, and it is the ammonia molecule in the uric acid that actually whitens teeth. And up until modern times, ammonia was used in all kinds of whitening and toothpaste products.
During the Middle Ages, people began bleaching their teeth to whiten them.
The typical thing is you went to your local barber and he applied a paste which was largely bleach. It definitely whitened your teeth, but it ate the enamel off.
Over time, the practice led to massive tooth decay.
You have many rulers in Europe who early in their reign had very white teeth from all the bleaching, but as their reign progressed, they were in constant agony, almost demented from the pain, because there were no dentists to speak of. There was no one to take care of tooth decay. You either got someone to knock your tooth out or to pull it out with a string.
In the centuries to come, milder bleaches were developed. By the 1990s, dentists began bleaching teeth themselves. Tooth whitening technology has now progressed to include home bleaching kits. Crest White Strips, which are plastic strips covered with a mild bleaching gel, were launched in 2001. Speaking of launches, have you ever wondered how astronauts go to the bathroom? Next, going where no man has flushed before. Today, bathroom tech has become so advanced that it can seem like science fiction. The Moen Company has developed high-tech computerized showers that have more jets than an air show. In Japan, the Toto Company has developed combination bathtub saunas, as well as self-cleaning whirlpool baths. The California company went one step further and created an entire self-cleaning bathroom. But to see the true future of bathroom technology, one only has to look to the sky.
3, 2, 1, 0, and liftoff.
Bathroom technology in space has come a long way from the first flight, when rocket scientists seemed to think of everything except what to do if an astronaut had to go to the bathroom.
That was something that they didn't even account for in their design. And when Alan Shepard first went up in the space capsule, it was a short trip, but he had to go to the bathroom on launch. And rather than delay the launch, all of the engineers came together, thought about what it would do, and told him just to go in his pants. So he made the trip through space in wet pants, but survived. And after that, they started thinking about waste management.
NASA's first official bathroom technology, developed for the Mercury, Gemini, and Apollo missions, was definitely low-tech. Astronauts were given plastic bags.
There was a bag for urination, and there was a bag for defecation. And I would coin them the pee and poo pouches of the space world.
Engineers soon realized the bags weren't a permanent solution. They often leaked. And there was a bigger problem.
Body waste in space actually tend to stick with you. And that's why I kind of use a friendly term of sticky. But, you have to overcome that force.
When the space shuttle was on the drawing boards, NASA engineers knew that they had to create a working toilet. They had to address not just the environment of space, but human anatomy as well. The toilet they came up with had two parts: a sit-down commode for solid waste and a handheld urinal to take care of liquids. Both commode and urinal use suction to remove the waste.
We call it air entrainment. Basically, you're sitting on the inlet to the fan. If you ever can kind of conceive of this, of taking your vacuum cleaner at home and kind of sitting on it.
Calibrating the precise level of suction was tricky, especially in the urinal.
We have an airflow that is gentle enough to remove the liquid from your body and pull it down the tube without getting back in the cabin, because obviously you'd not want to have the little yellow raindrops floating into the cabin.
For sanitation purposes, each astronaut is assigned his or her own urinal funnel.
We do have a female funnel, and this will now fit the proper geometry, or basically you can even stand up for your rights in space. The ladies can.
The air used by the toilet's fans had to be recycled as well.
Physically, it has to go through a downstream fan and then goes through an odor bacteria filter, and voila, comes back into the cabin, and you've got nice fresh air again, hopefully.
Zero gravity also meant that something was needed to help anchor the astronauts to the toilet. Designers solved this problem with the addition of thigh bars that swivel across the lap. And while astronauts still use toilet paper, they must use it sparingly.
You'd wipe yourself, put some of the crucial wipes in the bowl, and then you would put the extra wipes in another little receptacle and put in the trash later on.
1,000.
Each time the shuttle lands, the space commode is full and must be serviced. Since this arrangement wouldn't be possible on a permanent structure like the space station, NASA commissioned the next generation of space toilet. This model uses individual bags beneath the seat. The bags are constructed from a Teflon-coated plastic that allows air to pass through, but not liquids or solids.
I will now insert a bag, but you can see the airflow pulls the bag down and deploys it, and we set it right there. Okay, now you'll put the seat down and you're ready to use it. So you float over to it. Again, you grab the thigh bars and hold yourself down. Otherwise, you may have a premature liftoff from the seat. You want to make sure you stay right here while you're doing your thing.
When the astronaut is finished, he or she covers the bag with a special Tupperware lid.
What you do now is you put it back into the compaction mode, push the compaction button, and there's a piston here that'll squeeze the bag down into little people patties at the bottom of the container. And being a good neighbor, you come over and put a fresh bag in for the next use. Okay, you put the seat down, and also remember, guys, put the lid down.
When the container is full, one lucky crew member is assigned the task of removing it and transferring it to the spacecraft's waste receptacle. The canisters can then be brought back to Earth with the rest of the trash. For now, the space shuttle's commode is still taking care of business the old-fashioned way, providing astronauts with at least one of the comforts at home. It's a different story for spacewalks. Astronauts must don suits and go outside for up to 8 hours at a time without a bathroom break. How do they get around this?
Right now, all the men and the women both wear diapers. Diapers in space actually work better than on the ground, because in space, really nothing drips, because there's no gravity.
Shuttle designers also had to address ordinary bathroom hygiene as well. Given the weightless environment, showers wouldn't be practical. The solution is body washes and shampoos that can be toweled off rather than rinsed. For each day in orbit, an astronaut is allowed 2 washcloths and 1 towel for personal use. And since spitting in space would be problematic, they had to develop toothpastes that the astronauts could swallow. Of course, communal living aboard the shuttle requires everyone to pitch in.
There's no janitor there to physically clean the bathroom for you. So I like to tell young kids, go home tonight and do some early astronaut training. Help your mom and dad clean the bathroom at home, because someday you may be doing it yourself.
In the space of 200 years, bathroom technology has evolved from holes in the Earth to a computer-driven commode that orbits 200 miles above it. And if human beings ever plumb distant galaxies, one thing's for sure.